Hello. So I'll continue the process here of building out the UI. We refactored it. Let me see, maybe the submit UI elements here. Yeah, we can actually do this twice, so we could also and then text clear primitives. Yeah. And let's maybe let's do 600 pixels and 5 on the Y here. Okay, and let's do it a bit more narrow. Max width, max height. Let's see. 500 pixels, maybe middle of the screen here. Okay. There is some bug. And let's see up here. Max width and height. Let's see, 100. Doesn't it even register? Well, it does. Huh. Max width. Uh, 400. Well, 10 pixels. 1 pixel. Yeah. Let's see, when we build our primitive, let's see. So when we build our primitive, we pass in our minimum positions here. Well, then in the rendering stuff, we need to yeah, we would like to specify the minimum and maximum points of the rects themselves, because if we are to do overlap checks, we would like the minimum and maximum values to be correct. So we would rather simply draw like this and calculate the width and height. There we go. Yeah, now it works. Okay, let's see. Okay. We have our context. Um, let's see. Uh, let's see if we. Hello, man. What's up? I'm redoing my UI system. Oh, well, nice. Welcome. Well, I'm not a professional programmer, so use what you can use and ignore the rest, I'd say. So let's create a static bool button. Let's do a string temporary here. Name. I've gotten pretty far, but yeah, and I know well, more than nothing, but yeah, don't always do as I do. Uh, let's see. Whoops. Sorry about that. And we have a small vec2 here. For the UI, which will be defaulted to vec2. Well, that's probably the best way to go at it anyway. Just keep with the stick to C and you'll be all right forever. I mean, it's like the best programming language there is. If I could start over, I'd do C for everything and never use C++, but I think I'm stuck because now I've done C++ so much that it would take a long time to relearn everything in straight up C. Maybe just the label here. Let's close these old ones here. Well, I'd rather do C++ than C sharp. I know C sharp and I know Java, and I don't like those languages. I can sometimes I have to use them where if I do an Android application or something like that, or maybe a WPF interface or something. But I do prefer the possibilities of C and C++ a lot more than C sharp. I find C sharp so easy to memory leak in, and yeah, I don't like the garbage collection, and I don't like the slowness of things. So yeah, but I'll use it if I need to. So it's not that I don't have a problem with Oh yeah, we need to pass along the context here. We need to do that for every item here. P context. How about you? Do you have any things that you want to learn or that you're curious about? So we will check here. We'll take in window pointer current window, which we'll set from our context current window. And yeah, we could add skippable items for the window itself, i.e. if it's collapsed. Yeah, I've done a neural network, and I also looked up different research papers in terms of what is called triplet training and different algorithms in terms of optimizing the training algorithms. So yeah, it was fun diving into research papers and so forth. There are some pretty interesting ones. Yeah, I just did it the hard way. I built everything from scratch in C++ except the math components where I used the library Eigen. It worked fine. Um, Eigen doesn't support tensors, but you can just create vectors of matrices, and thereby you have tensors because they are just 3D matrices of sorts. But yeah, You you could definitely just start with Python. It will be more slow than if you do something in C or C++, but you might not need the speed. The great thing about doing it in C++ is that you can use multi-threading for is for example for triplet loss calculations. You could do batches over separate threads if you had the memory capacity for it, and yeah, things get way faster when you do it in a low-level language. All the Python languages are probably written in C or C++ anyway, so. Okay. Let's see. Yeah, that's a nice thing to learn. It'll help you in whatever you need to learn. And if you can stomach the math, I do find it pretty fun. But yeah, I guess it depends on what you find fun, and yeah. Python has a lot of different visualization techniques as well, so I think that's a great way to start. Let's see. Uh, Thank you very much, man. Thank you for dropping by, and good luck on your endeavors. Hope to see you around here soon. So we need to look up our window here in terms of mm, creating an item here. Yeah. So we want to calculate an ID, and since we right now expect to call this this part of the program every frame, let's do a series of std vector unsigned ints item IDs. So let's do an ID here where we ask our current window to, well, when we create our window, we actually want to reserve one item in our stack here. So when we create the window, we want to item IDs, we want to reserve this by 1. So that we simply create one empty item. It will just be 0. We will also use that for our window headers if we have window headers on our windows here. Windows. All right, so when we create a button, we ask for our current window item IDs back. And we plus that, or rather add 1 to it. That's how we're gonna handle our IDs for our objects now. Or maybe handle system C++. Do we have a window ID actually? We do have an ID here. Well, we could implement a handle system. Yeah, we could do that. Let's see. Let's see. Let's see. Okay. When we create a button, we want to set the position. Let's see, let's add some frame data here. Struct window frame data. And let's do a vec2 cursor position, which will be initialized as 0, 0. We will reset our frame data here. Let's do that when we create the new window here. We set our frame data. Let's see. Void clear. Cursor position that x equals 0. Cursor. Maybe just memset this and value 0, and then size of this. Let's see, can we use that function to clear our UI, or rather window data? Will this work fine? Probably. Yep. Okay, the button will spawn in with the position of our current window. Frame data, cursor position. Let's set a size to our calc size. Input size preset. Let's do an R size instead. Let's see, blah blah blah. Because we will copy that value. we will create a rect here that is bounding volume, bounding box, which is equal to our position and our size here. Now our position plus our size here. Let's see, the operator here is not existing, so let's just type it manually. Position X. I can't spell. Plus the size dot X, comma the position Y plus the size dot Y. Then we want some function here, which we will declare inside the namespace here. Class and namespace and so let's create a bool function window add item. We will take a context pointer, p context. We will take a rect bounding volume, and we will take a const unsigned int ID. This should also be const reference. We don't want to copy it. Great stuff. We will add this as a helper function because we will use this time and time again. So window pointer current window is equal to our context current window. we should do some visibility checking. Yeah. We need to do some mouse over checking. Probably at least when we create it. Let's see. And we of course want to return true if we run through everything. Let's see, so we simply increase the ID up here. Uh, let's see, our struct here uses our min and max. Hello, I'm doing all right. How about you? Let's set a clip rect, which is our clipping area of our window. Clipping area. Let's store these down here together. These are kind of like settings in terms of width. These are data points. These are rects. Right now, when we create a window, we want to right now hard code our current window clipping area. We will set it to our rect here. For now, we will do our entire clipping area, because then outside in this function here, we can check if we add a function here. Hello, buddy. How are you doing? Bool rect overlap. Rect overlap. Let's see, and let's do a rect reference. One, and let's do this const, and a const rect to const function here. Oh well, doesn't matter. We won't be changing anything with this one. So if one dot let's see. Okay, let's specify the names here. Why aren't you fine? I'm all right. Container and checker. Let's call them that. So we will check if the volume ref container, let's call it that. So we will check if the volume minimum. Oh, I'm sad to hear, man. I hope it gets sorted. So this should be bigger than the ref containers minimum, or at least the exact same. Also, the volume minimum y should be larger or equal to the ref containers minimum y. Also, we'll have our next line here, volume maximum x needs to be smaller than or equal to the ref container maximum y. And finally, the volume maximum y here needs to be inside the ref container maximum y. If that's the case, we will return true, otherwise we return false. So now we can do if let's see, bool is visible, and then we can rex overlap. And we want to take our current window clipping area and compare it to our bounding volume for our button here. If it's not is visible here, we return false. Mm, uh, uh, let's test this, of course. Uh, let's see. Uh, Maybe we want. Do we have a mouse position? Well, we do. Hmm. Hey, buddy. I think he might have left the stream for now. He might be back later. How are you doing, Penguin? I think he'll be back in a while. He usually does come back, but maybe we want our input system here to be able to poll for our when we create our input system. Well, we could also just grab it manually for now. Well, I like it. I'm not that good at finding names for things, so well, John Johnson will be plenty fine for me for now. So we check if it's visible. If it's visible, we draw it. Let's call if window add item with our current context and our bounding volume here and our ID. If that doesn't work, we will return false because Coden? Alright, I like that as well. That's not a bad name. Okay, let's do a function here that rex overlap. Did I not? Let's see. Function definition, rex overlap. I do think that. Well, that should be it, right? Maybe IntelliSense is being annoying. the definition declaration. Member functions, global. Okay, I don't know why it doesn't register that, but it's just a warning, so we don't care. Okay, let's see. Bool is mouse over rect, and we will take our back to, oh no, let's just do a rect const rect bounding, or rather area, or rect. Okay. And we will use some Windows functions here. Do we include them inside of this? No, we don't. So let's do that. Windows dot header, and let's see. Get mouse position. Wow, let's Google these functions. I can't remember them. Mouse position. Win32. Let's do this for now. Our let's see, client. I mean, okay, let's do a get cursor position, and we need to store that in a LPP point. 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 And then we need to use screen to client handle get handle from point. Let's see. Get window. I can't remember the function. Get window handle from cursor in 32. Handle from window point. window from point. And we change that into a pointer. All right. And we take our handle. Let's see. So let's print our mouse plus point.x point.y, and we do if is mouse over rect, and let's pass our bounding volume here. Mouse over. Let's see. Did we actually add the button to the no, we don't. So right now let's see. Test button. Whoops, we of course need the context pointer. Okay. Let's see. Let's do like this. Well, this subscript is still out of range. Okay. Do we crash when we get into this? No, we don't. Oh, it's the reserve, of course. Let's do a pushback here. 0. We might want to change this in the future. Okay. Let's see. Do we end up in this state? So our ID is 0. Our well, our size is 0. Let's temporarily set this to something like because a 0 size there. Oh, that sounds nice. And yeah, at least you're getting somewhere, right? So let's see. Okay. So the button position will be our cursor position. Let's just step through this function here and see what gets created. So our position is 0.0. Well, cursor position. Do we not initialize the frame data? Probably not. Okay. Let's see minimum here. Maybe this is more right. Our position is right now. Oh, that sounds interesting. A push constant. So our bounding volume here is, yeah, seems right. Uh, seems right. Let's step into this. Let's step into this. So why isn't this true? We have our reference container, which has the minimum. And the maximum. Oh, this one needs to change. That's why. Yeah, we return true now. So it's visible. Let's try getting the cursor position. So we can disable that. Let's see. Does this? Yeah, it actually maps into the uh, window position. So we can then use this as if we have an area. Let's see if the mouse position is point x is lower than or higher than or equal to area minimum dot x, and the point y is higher than or equal to the area minimum y, and the point x is lower than or equal to the area maximum x, and the point y is of course lower. And yeah, well, there we go. Okay, so let's see. Okay, so we get a mouse hover right here. So now we can track whether the actual mouse is over the bounding volume. Yeah, well, 128 bytes are pretty standard in terms of alignment in on the GPU, it seems. Okay. Okay, so we added our item. We can check if it's the mouse is hovering over it. Right now we don't care. We just want to know if we can actually draw it. Otherwise, we won't. And if we won't, we will of course return false because there will be no button created. Right now we hardcode the button size, but we will adapt. Well, yeah, I know that feeling. Maybe take a break. Sometimes you realize what the bug is when you take a break and don't work on it. And sometimes you just have to redo everything. That's why I ended up solving the bug in the quaternions inside the physics engine. I really spent 3 weeks on that bug. 3 freaking weeks. Uh, let's do a bool process button info. Hmm. Is button pressed? And let's do a bool reference out hovering. Yeah, we can do that. Mm. Yeah, maybe you need some refactoring or cleanup. Or maybe just a break from it. It sounds rough. Uh, uh, we will of course need the context here as well. Bool is pressed equal to is button. Let's implement this. Is button pressed? P context. Whoops, did I swap the order of this? Maybe IntelliSense did. Okay. Let's do hovering. Let's get our rect here. Bounding volume. Our ID and our hovering reference here. let's process return pressed here. And then we need our input system as well. Well, right now I have enough work on my hands so that I'll probably skip that for now, but maybe in the future. I really want to be done with the level editor, or at least parts of it, so I can do a third month update. So yeah, let's see. And let's just set the bool here, hovering mouse, hovering equal to is mouse over rect. Let's pass in our rect here. Okay. Yeah, we want some sort of handle system here because we might end up. Yeah, thank you very much. Things have been going really great in that terms on that term, but and we also seem to be earning a lot of viewing hours, which is also needed for the expanded features of the YouTube stuff. So yeah, things are really going great. Thanks for all your support so far. It's been amazing. Uh, okay, let's see. Uh, I think I need a... Yeah. It's quite alright, as long as you're doing well, and yeah. I mean, we need to move to a handle-based system for these IDs. Uh, okay. Uh, sure thing, buddy. Good luck. I hope it resolves quickly and fast. Quickly and fast, that's the same, but even faster than. Okay, so the problem is when we generate these IDs, I would like to be able to compute an integer. So let's say that we want a uint 64 handle, which will be 0. We will compose this of a uint 32 maybe not 32, maybe window ID mm, whoops, ID of course here, and item ID, which will be our ID here, and then maybe a counter, or rather version ID. Maybe just actually, maybe the label.cstring cast as a uint 16. Hello, buddy. Wake up. Okay, let's see if we can compute our handle. The first slot should be our window ID. Then we should add our item ID, bit shifted, uint 64. And then we want to add our sub ID here by bit shifting that 32 bits. And then let's print out our handle here. Handle. Okay, so we have a handle here. Welcome. I'm making a game completely from scratch. Right now you can't see it because I'm messing around with the UI. So I'm also doing a custom UI here. I'm rewriting everything. Let's do a programmer here. So double word, keyword. It will be like a Doom clone slash Quake clone, maybe Star Wars game clone. No, I do the UI completely from scratch. I did this UI here, but decided that I wanted to rewrite it. Consists of, let's print out the window ID plus the item ID plus the sub ID here. And let's see how our handle gets computed. So our, yeah, it's a lot of work, and I wouldn't recommend it unless you want to use a lot of time on it. I'm working on rewriting the UI system because I don't like the way that this one here got done because I might want to do multi-threading in the future, and that system didn't allow me to do any threaded work. So yeah, I decided to rewrite everything and make sure that each thread could have different parts of the UI, so that the CPU doesn't have to spend too much time rendering a complicated UI. So the sub ID is the last one, which will be these bytes here. Okay. Let's do a uint 64 here. And let's see if our output here changes. So we set the first 16 bits to our window ID, which is 0, and then our item ID, which is 1, and then could we actually do something like just this for testing? 13 and bit shift that 48. Let's see. Yeah. I've been working for this on this for exactly the whole game with the physics engine and so forth, like this dude here that you can see in the background that I can throw around using a physics engine, and the whole 3D rendering. Whoops. Well, there's some bug there, but I've been working on everything for 3 months. Spare time. I'm not working full time. Um, I'm working another job on the side. I don't have time to do much work on this. So maybe if you convert it into full time, maybe I worked about a month or a week or I don't know. But it's definitely not much. Okay, let's create a handle algorithm here that will return a uint compute item handle, and we will pass in an constant unsigned int window ID, a const unsigned int. Yeah, yeah. I worked in Unity before, um, and also Unreal Engine, and doing it that way is way more easy. So yeah, I wouldn't recommend it. Label int. Okay, so the idea is that we compute a handle here, just the way that I've shown. So instead of the old ID system, we will create unique handles here. And let's return the handle. And let's truncate whatever information we get here. We shouldn't be overflowing at least, and we can always manipulate the let's cast these so that we truncate whatever we need. And yeah, it definitely gives you a basic understanding how a complex program with different systems and different um, data flows work together. So on that part, it's pretty fun. So let's see. We will change our window information here. Item handles, let's change it to that. Now we know that the first bit is always the window. The second bit is the hello man, welcome. Then the second bit field is the unique item ID, and then its interpretation of whatever label it has as the unique identifier. So let's do something like a uint64 handle here, which we will compute from compute item handle, the context, current window, current, we already set that, current window actually. as a pointer ID here, and then we simply pass in our size, or rather, right now we should set our window item handles size, and our label will just be our label here in the C string type, converted into a const unsigned int by hard casting. Car pointers can be cast as integers. Let's hope it doesn't overflow. Let's see. Item handles instead. Let's see. We could compute handle here for the header. Actually, I think I will delete this for now. And we will also want our handle here instead. Handle here instead. And let's change this so that it takes a uint64 handle instead. We don't use it right now, and I don't think we need to check for this right now. The handle calculation is there. Let's do a uint64 here. Handle. We could do this by reference, but copying an integer instead of a pointer, wow. If you were really interested in doing that, well, be my guest. Let's see. Let's do a uint64 here. Handle. There we go. Okay, now we have a way of discriminating. Let's see. Let's see. Maybe we want to this button pressed. We also want to parse some information here. We want to store whatever we are hovering right now. This is frame data. Let's set a uint64 hover handle, which we will set to 0. So whenever we call update each frame, let's set the context hover handle to 0, so that we inside here can say ask is rect is item hovered. Let's pass in the context pointer. Let's pass in a reference to the bounding volume of the actual item. Let's pass in the handle to the item. And let's leave it at that. Let's create a method. All right. Let's start out with is mouse. What do we call is mouse over rect? If it's not over the rect, well, we know that we can't be hovering this. We should probably return true if we reach the end. Let's ask for the context here. If we actually have a registered hover handle, which is set, and if it's if it's different from our current handle, well, we can't be hovering over this item here. If the handle is set, we can do some computations here. And we can set our context here. Hover handle equal to our handle. Maybe we want to do some parsing on where we hovering this item last frame as we did in the old UI. If so, set some data. And Well, I guess that's it. Yeah. So that's it. We store our hover ID here. We return true. So when we let's do item hovered instead here. We pass in our context. We pass in our bounding volume, and we pass in our handle. There we go. And now we can set a differentiated color here. Let's do a gfloat. Do we actually specify that inside our calls here? Let's see our draw calls. And let's do a gfloat for color. Okay, and let's set that to simply be maybe just black. With no transparency, excuse me. Window ID, there we go. Item ID, there we go. And of course, when we compute the render data here, we want to ask for the draw color instead. Let's disable this. Now this looks neat and nice, and should be possible to multi-thread. Let's see, and our draw color, which we will set to our white-ish, because we just want to see if this resulted in a change. We will, yeah, it resulted in a nice change. Okay. Let's do another helper function, I think. Add item. Adding stuff to Windows and their data. Let's do checks down here. Checks. let's do a item pressed instead here, because system stuff. Shouldn't matter, should it? Oh wait. Item pressed. Let's see, no definition, of course, is item pressed. Okay. So now then, when we add our button here, we can set our gfloat color to be dependent on the hovering. If it's hovering, well, then let's set it to a red color. Otherwise, let's set it to a, well, blue color. Am I not allowed to do that? Maybe I can't. Oh, wait a minute. Gfloat floor. Well, we should be able to ask if the bool is correct. Did I do something wrong? Expected an expression. Uh, Maybe we want a gfloat for constructor. Maybe it doesn't understand what we're trying to do here. Seems like it's okay. Add now draw rect window, because we want to add to our window here. Bounding volume and our gfloat for reference color, which will be const. And we would like to add a potential border. let's do a, well, we could do a style setting somewhere. Can't spool border. And let's declare this. Okay. We will grab our window pointer. Window equals the context current window. We will ask our window here for its draws. And we'll let's see. Need a vector 4 there? What do you mean? So let's see. Hmm. Okay. Let's see. We will create the background, which will consist of our border. So if the border is set, we will create a draw call here where we set it to the actual bounding volume here, and then this will be our outline. Draw border, and then we will do a draw call base. We will set our draw border color here to be black for now. Our base here will be our rect equal to our bounding volume. Let's see. Let's create this inside here. So the bounding volume minimum.x minus 1 and the bounding volume minimum y minus or plus 1 actually plus 1, yeah. And then the second part will of course be the bounding volume maximum x minus 1 and max y minus 1. All right, so and the base color will be set to our color here. So we add our border, and then we our base here. We could move this because we don't need to store it. Probably it's the same, but yeah. So let's try that. Let's see what happens. Oh, we don't call it yet, so we of course need to do that. In our button here, we want to be able to create our p context, our bounding volume, our color here, and let's do bordered. Okay. Let's see, we should call this let's see, let's set our transparency here. So we can set the transparency to 0 here. Well, probably not then. Don't I allow for that? Let's see. Record button rects overlap. That's end of class. Let's see, so create render data, color, and in our shaders we don't do our UI here, vertex shader, color, pass along the color. Okay, we actually sampled the texture, so yeah, we have no way of overriding the alpha. But we can disable this draw, yeah. Well, we don't see anything, do we? Nope. Why is that? Our render data here takes our minimum and maximum values and computes. Maybe they don't get set during the bottom stuff here. Button, not bottom. Let's see, let's step into this. The bounding volume here. Draw border. Let's see, our window pointer here draws. We have one draw, two draws. We have three draws. Do we want to draw them in the opposite order? Let me see, whenever I step into this function here. So window has these draws, the UI element here, position. The next element here. Is it because of the draw ordering, maybe? Yeah. Let's try doing something like for int I equals the window draws dot size -1, I larger than 0, I minus minus. Let's try doing this instead. So I Windows draws I. Let's try replacing that. It might pertain to the draw order. And let's replace that back. Now we do draw our rect there. Hello, man. Welcome. How are you doing? So let's see. Our I is 2. Well, that's good to hear. It's a nice endeavor. So let's see. Then we subtract 1. Oh, this needs to be an equals. All right, so now we draw correctly. Didn't we do that before? Let's just check that. So yeah, it's definitely the draw order. If not, let's see. No, it's the draw order. So we need to draw the background last, because otherwise it will or rather it will block for whatever is in the foreground. So yeah, we flip that. Oh, great. It's hard, but if you stick to it, it's really good. What are you working on? Any projects to learn the coding? I would like this to be down at the very end here. Pass data out to D12 renderer. All right, great stuff. So let's create a bit bigger button. I would recommend that you learn the C language instead, because the compiler in C++ is so hard to understand. So, all right, our button gets created here. We have a 1 pixel border, which looks fine. Oh, we actually forgot to set the out hovering here to mouse hovering. Oh my god, wouldn't you know? We simply have a hoverable item now. And with far better code than we actually had before. I mean, the old UI system was so messy. It was so messy. Let's see, pressed, we need to do some computation here in terms of pressing the button. We aren't actually done yet. We also would like to modify our Renderer UI helper here. We want not only to be able to build a primitive, but we also want to be able to build a text that is clipped so that we can define a clipping area and make sure that the text doesn't get rendered without overflowing. So yeah, let's do some stuff here. Uh, 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 oh man, I really like this version much better already. I mean, we could simply do something like the input, not input system, uh, get click position. We would get a input mouse position. I think 0 is the left mouse button. Yeah. So we could simply check like that. So if we're hovering, we can check if we clicked it. We don't need the position, even though it's nice. We could simply mouse position. We could We could also get click position. We could expand our UI system here so that we could simply ask, did we click the left mouse button? Let's do that. Let's do a static bool is mouse clicked button was mouse released. Let's create these two functions here inside our input system, and we will do some switches here. So is it clicked? We will do a switch if it was down in this frame. Let's see. We will return true if it wasn't down this frame and last frame it was down. Let's see. And last frame mouse state 0 was down. Because then we must have clicked it, meaning that we released it. Otherwise, we would like to return false. And let's do the same thing down here instead. On this, we will just set the button offset here and return a true value. Otherwise, we will mouse released. We can simply do something like this. If it wasn't down, well, this is basically the same. Yeah, maybe we don't want that. A click involves, right now we don't need it, probably. Let's see. So now we can ask our input system, was our mouse actually clicked while we were over our our uh, our button here. Let's try testing this out. If pressed, we call a press. Let's see, we call a press, and if we click elsewhere, nothing matters, but we call a press here. That's already way better. Then And we want to of course set some kind of if we want to what was my train of thought? Okay, now I remember. If we want, we can store our active handle as well. We will have to reset that during our update here. At least for now, maybe we need some logic to this. We could do that, but right now we can store it inside our button here. Okay. And we will simply just update the handle. Oh, that's not the file I was looking for. Well, on the actual item clicked, pressed, if pressed p context active handle, we'll set it to the handle. So now we can do checks if we need to use that in the future. This is, for instance, if we were to have a text field that we were supposed to write into, when we set the active to something else, we know that we can no longer, by pressing our keys on the keyboard, actually affect the, what do you call it? That you no longer can input any information. All right. Great stuff. Hmm. Let's see. Okay, so next we should mm, add direct, add item, and if it's possible, we do that. Let's see. So mm, let's see. Okay. So we have a button, and inside our application here. Let's try if our new UI system allows us to do the exact same thing as we did before. If this succeeds, we want to print out, click and do stuff. Okay, there's a problem here. Because this... Oh, it of course needs to return is pressed. Okay, great stuff. Now everything works. So we successfully created our button. Next, we want to add a text widget. Which we had in our old what do you call it? Old UI system. Let's do a static void text, which will take a context pointer, context, and our label here, and a probably a size, although I'm not sure. Maybe we want to be able to create a maximum size for the area. So let's set that for now. So let's see. And let's see here. Oh, thank you for dropping by. Hopefully I'll see you around. Sleep tight. Let's see. Mm. Where can I find? So a text should be created like this. Let's see, create that. Maybe we only want a const char pointer here. Maybe that's easier. We could also change this into a const char point, but that won't allow us to create a temporary, as far as I remember. So uh, I will use this one. Mm, mm, how should I calculate the current cursor offset? I mean, um, the cursor offset here should be I could create it manually, but is that the way to go? Let's see. Uh, I mean, whenever I call uh, uh, so uh, um, let's see. Huh. What is the best way to Uh, I have some idea here. So, for instance, in our button here, after we've done this, uh, we want to okay. So when we do this, we want to do something like void recalculate draw cursor window. Let's just do a vec2 size and create a helper function for this. Let's do our window pointer, which will be our context current window. Let's see. We set to our line y value to be our window. Frame data, cursor position dot y. Well, no, we don't want to do that. Let's just do a const float line height equal to of 20.f or our window frame data cursor position dot y plus the size dot y max float, of course. Let's do some recordings also, so that we also can do computations. If we want that, we could do back to nah, we don't want to do that, do we? Do we need that? No. Uh, let's update the window. Frame data, cursor position, dot x. Or let's do and then do line height. Maybe just this, and then we simply use this as our new line. And let's set a vector here, cursor max position, which is equal to this. Let's see. Okay. So if we call that function when we have declared our window here, not window, our button here, we should be able to add another button right under it. Well, it didn't work. Okay. Let's see. Let's debug this. Maybe I need to do something like this. No. Okay, let's step into the function here. Whoops. What is going on? Please don't do that. What are we doing here? Okay. let's see, what did we get? Our position here, or rather current window, cursor position, frame data. Okay. So yeah, that's definitely wrong. So we're invalidating some of this. The window position X. Do we even set that when we created? Maybe that's the problem. No, we don't. When we create it, at least, we want to add it to our p context position X here, and the same for the Y. Maybe this will fix it. Let's see. Yeah. Okay. Great stuff. Did stuff 2, did stuff 1, did stuff 2, 2, 1, 2, 1, 2, 1, 2, 1. Okay. So now we have an increasing cursor. That's great. All right, let's do a text then. We don't need the input. We don't need the header for the application. None of this right now. We want to create a text. We will use our window as our current, let's just call it window. P context, current window. Okay. Let's skip this. And okay, I want to calculate some information here. Text start equals to the text. Text const char text end equals to the text plus the length of the text. This will return the size t, which will be added to the pointer. We will calculate a position. Which will be our frame data, cursor position X, window, frame data, cursor position Y. Mm. Uh, let's see. So yeah. So we will have to calculate some text sizes here. We have a function here that allows us to use a font for that. So we will modify this function here. In our old UI system, I think that we actually stored a font. Yeah, we stored a pointer to a font, which we would like to do as well. Well, when we do the initialization, we want to store a system's font pointer as well. Font. There we go. M pointer font equals font here. No. A non-static member. Let's do it static then. And let's initialize it outside. UI system to MP font equals a null pointer. There we go. And then inside our application here, we need to update this. Let's initialize the font here. Okay. Hello. Are you here? I didn't see chat until now. Did you end up oh, you haven't fixed it yet. So did you get the vertex buffer working, or is it still messy? Let's return it back to um, calculate text size, and we want to, let's see, where did we include that? In the data structures, maybe font, no. Font types, there we go. So we have a systems font that we can use for that. We want a systems font pointer font, and we want a const float max size. We want a const pointer text. Yeah, it's all right. Just leave it. Maybe work on something easier, or take a break, or yeah, enjoy yourself. Seems like you ruled out some parts of the problem there. So at least you have that. So we actually want to do something like, yeah, do you rotate the vertices directly, or do you use the shaders, or how do you do it? Because I suppose you should upload the view projection matrix and translate each vertex into clip space slash screen space. Almost all low-level APIs work that way. Yeah, yeah, okay. And inside the shaders, because you shouldn't. Yeah, because the rotation should happen inside the shader itself through the matrix. Let's see, we also want something like a const float scaling, which will be 1 per default. Okay, so inside this, when we build a text, we kind of translate it. Let's see. We will add our text here. Compute handle, let's close that. Is it hovered? Draw cursor window, blah, blah, blah. Is item pressed? Well, let's move this off down here. Now, up here, and then, or rather move the handled stuff as well. Yeah, so the handle stuff will be up here, but closed. The overlap and the mouse check here will be down here. Well, I'm sure that you will figure it out soon. Okay, let's see. Let's use this function here. Calculate text size. Let's do a vect size text size, which will be our font pointer, and just maybe 20 pixels here, and then we will pass in a temp text. Well, yeah, I did peek at the ImGUI implementation, so I saw how to do it more streamlined. Yeah, I figured that the implementation that I had done myself was not as elegant, and I wanted something more robust. But I'll soon be done actually rewriting this. We're almost at the same point as the old UI, but just better. We already have clickable buttons, and soon we will have text as well. All right, let's see for in I, and I is lower than string length of the text here, and I++. Let's print out val. Yeah, things are way easier this way because everything is basically a window, and I did some weird stuff where I copied a lot of different stuff and had to look up maps, and yeah, it just didn't work. So this system will definitely be more robust, and I think I'll appreciate it way more, and it'll probably be faster as well. So yeah, let's see. Oh, we need to add a text, of course. So yeah, I think it'll definitely be worth it because I'll be really fast at iterating from here when I get done. So yeah. And the old system started getting so messy that I really couldn't use it or extend it. And even though I took inspiration from the I'm GUI stuff, I'd say that I definitely made some other different choices. So text temp is the one that is using. Let's see. Let's call it with the label here, C string. Oh, whoops. The text here. Okay. FPS. And then the space. Okay. So this works. Now we need to calculate some data here. Let's see. The character will be our find character text I and our well, I need to include the font system as well. Systems, fonts, well, isn't it declared in here? Yeah. Yeah, I can change the base texture. So I can show you in just a second if you would like to see that. Let's see, where do we store our font utilities? Oh, they are in systems, font utilities. Oh, I was staring right at it. Okay, let's add it right here. And we of course want to pass in our font here. It wants a font reference. Well, it'll get a reference. Okay, let me see. Let's just compile this. Okay. Okay, I'll jump into the renderer and change the UI rendering pipeline here. Let me just close this. So the UI is drawn here, and let's see. Let me just look up the root signature. I can't remember what is stored where. So our parameters, view projection, model translation. Okay, the third parameter is our descriptor table. So this should be our descriptor table. So this should be our base texture. Let's increase it to something weird. Well, that didn't change anything, I think. Let's see, maybe 5. Oh yeah, now we have a transparent one. Okay, so let's test them one by one. Well, this one is not interesting. Well, what about this one? Not interesting either. Oh, we can change them during hot reloading. 4. Let's see. No. 5. Well, now they at least get transparent. So this is probably some transparent texture. I can't remember which one it is. Oh yeah, this looks weird. As you can see here. How do you like that? It uses the alpha channel from the texture itself. Otherwise, it just colors the pixels with the specified draw color. So yeah, yeah, it's because of the way that UV mapping works. So DirectX is weird in that regard. Let's see. Now this also looks pretty weird, huh? Pretty stylized. So yeah, it only uses the alpha channel of the texture, so transparent textures look more funny. You could make parts of the texture transparent and do different effects by that. You could also kind of like make a UI element have rounded borders or whatever. Yeah, as long as your scaling was correct. Okay, so let's copy this. Mm. And we pass it by reference, so we need to dereference it. We don't want the UV coordinates, we want the... Yeah. Right now I'm just expanding it so that I can get the basic features. I want buttons, I want text, and I want a list of items that I can click. So I can start showing all of my different meshes in lists, my objects in lists, and then the next thing would be probably something like, well, maybe something like, yeah, text fields where you can edit stuff. But yeah, yeah, exactly. It is a game engine. Let's see, this will be in pixels, so no need to reshape it. Yeah, exactly. That's the idea. So I can easily make a level editor. Hopefully I'll get done with the level editor tomorrow. Or at least be ready to showcase some stuff. I want to be done with the list stuff tomorrow and set up the basic stuff. Okay, let's see. So what did we do inside? Oh, I changed this one. I shouldn't change this one, of course. So the padding. Okay, let's copy this. Okay, let me copy this. Oh, I already copied that. We don't want this. We don't want this. We don't want this. We want this outside of here. Let's do. I don't think we want Y padding, at least not for now. We don't need that. We don't need to translate that. X offset. We don't need to do that. Float X. Actually, we don't need any of these parameters. Yeah. I should be able to save states, if you know what I mean. Not only maps, but I'll create a level editor where you can save the map to a file and then load a file. And yeah, then you can edit everything inside the engine itself. But also, I would like to, yeah, sort of. Let's see, do I not need any of this? Let me see. How do I advance? Okay, the X advance here. Font. Let's see, file systems here, font, file handling, font loader. Multiplayer is probably a project for when I get really, really old. Yeah, multiplayer is hard, man. That's really, really hard. I know nothing about networking right now. Let's see. Do we have any information on our fonts? I can't remember what they do. The different parameters here. Okay. Let's see. So if the X I think even though it's a nice idea, I would suspect that mm, I would suspect that it would take a long time. So we advance our cursor here. If we have a max size in terms of pixels, let's see, max size, float minimum Oh, that's overlapping. Calc max size. If okay. If x was lower than our max size, let's update calc max size to our x here. Else we break. Sure thing. Sure thing. I'll hopefully you will be a game tester if I ever need a game tester. You can criticize what I make all you want. I have no sense of what do you call it? Thank you very much. I'm a web I did web programming when I was a teenager, and MySQL and dynamic stuff, also jQuery and stuff like that. So web pages aren't any problem. It's more like all this stuff here instead. That's uh, I even did Flash back in the day, even though it was not very nice dynamic database linked Flash applications. We will do this preemptively because we just want to end. Okay, let's see. Let's return AVEC2 with the X as our calc max size. But we want to do this after increasing the X because we want the last calculation if we end up actually doing the whole string here. But maybe we want... How do we know how high a line is? Does our font here actually store any information about that? Size 32, line height 48. All right. Let's do that. 48 times the scaling factor. All right. All right. So now we have the ability to calculate some text size here. No, I haven't tried that. Is it nice? Text size, calc. Yeah. Okay, so 19, let's do maybe 500 pixels as the maximum. Okay. So you can do 3D rendering in a web application or something like that? Yeah, I know. But I was wondering on the WebGL stuff. Mm. Yeah, there's also the thing called WebAssembly where you basically write a C++ program and run it in your browser. You should look into that if you want to do web wall a web Vulkan API or something like that. I don't know if it's possible, but it may be. Mm. Okay, let's do a rect here. Bounding volume, which will be equal to our position. Let's do the minimum first, the position that x plus nothing, and the position that y, and then the maximum position. Let's copy this. plus the text text size. X and the I think you simply just write a C++ or a C program and then it compiles it into WebAssembly. If you have the correct make file. I don't know what you can do with it, but I just saw it and got somewhat excited. Okay. Let's recalculate our draw cursor window. Let's pass in our context here. And let's pass in our text size. Then we want to do what we do in the button window add item. If window add item, our p context here, our bounding volume, and our handle will be 0. If not, return. Otherwise, we will add it. We will add a new function here. Void add draw text window. Context pointer p context. A const vec2 reference position. A const char pointer text. A const float max length. Max size. Let's do like that. Yeah, I used both Unity and Unreal. I actually did a multiplayer thing in Unreal. It was not very advanced, since I just messed around with stuff. And in Unity, I did some parts of a platform game. Or, yeah, a platform game, but we didn't develop it very far. No. I don't even think I have Unreal Engine installed on this machine here. Let's see. Okay. Yeah. I have done some different stuff in Unity. It's quite alright. I just yeah, wanted to do my own stuff. No, man. I don't think I have them anywhere. Maybe on an old disk or something. They weren't any good anyway, so hopefully this project will be better. All right, let's see. So when we calculate our create our render data here, maybe we should just make a separate buffer for text draws. Do I even clear that one on the update stuff here? Draws here, I do. So when we want to add text, we of course do it a bit differently. Yeah, I think I'll do a different buffer. Well, I think the development time on this game engine is pretty long. mm, okay. Draw rect and a struct draw text. Is this a macro somewhere? uh, let's just add a C here. And I like to talk to you also. I'm happy, man. Let's store the text here. And let's store the color as well. And then well, we could actually, let's see. Oh, I forgot to do something here, or what? Where are we having an error? Oh yeah, okay. Draw rect instead, and let's do a draw rect here instead. Okay, so what we could do. Oh, that sounds awesome. Yeah, that's an awesome project. Well, maybe you should just refactor it a bit and make it more streamlined so that you can find your way in it. I refactored my renderer. I've started refactoring my UI before it even was done. Don't worry about that one. Let's see. Maybe we want something like a int reference out. Let's do a pointer instead. Int pointer out and index. Let's add that and draw rect, and let's do that as well. Null pointer here, because then when we do the text size. Yeah, sure. I think I created a private channel for us that you can just use if you don't want to share it with everyone. At least you're the only member who's invited for now, so we can just keep it that way. And let's set our out and index. If it's set, then we will set this to our I value. Because now we can store which index we want to cut off, excuse me, our text. Which means that now we can do, let's see, calculate text size. Let's do an int index of bounds. And let's store that as the null pointer here. And let's see. Index of bounds. Let's see. Let's print out that one. 0. Okay, we can't show any text. with this small clip. Okay, we can show about 2 characters with this, and let's do and if we can show all characters, let's see. Let's see, int max index equals -1. Whoops, we need to set this to our max index instead. There we go. Is it only... No, it's not only allowing us to draw one, right? Let's do 500. 72, let's do 50. Yeah, let's do 80, and then it will be 0. Let's see, what am I doing wrong? I mean, let's try stepping into it. Let's step into this function here. Okay, we have our text here. Then our x will be 36. Our max size will be 80. Max index. Okay. And let's just set this here instead. Okay. So now we can set our index for our bounds. Let's do a test string here, test string, erase. Okay. So if we had something like this equals to our text, and if we erase our index of bounds here, and we print out our text. Test string C string. FPS, if we limit this to 20, test, well, nothing will be rendered, then 40, F, 60, F and P, 70, FPS, and then the last part doesn't use a lot of okay, so we can basically use the string wrapper here to cut off whatever max size we want, and then we want to add a edited string. There we go. And then we will add draw text window and pass in our context here, our position, our edited string, .c string. And let's just set a max size of 0 here. I'm not sure I need it anymore. I'm actually not sure I need it right now. Let's remove it. For now, we will well, maybe we just want to pass the string along since we're using that anyway. Yeah. Let's do a const std string reference text instead. Okay. And instead of this, we will pass in the string itself. So now we can store our truncated text call here. Let's do a back2 position, which will be initialized as 0, so we don't need to do that. And we will register some text draws here. Draw text, C text draw, or rather text. Now that's draw. The text will be our text here. Our position will be our position, and well, we also need a color. Const g float for reference color. Let's add that to our function. There we go, and the text draw color is equal to our color here. And then we will ask our window here, can we please get your underlying draw calls for text, draw text C, draw rects, draw texts. Can I use that? Will it compile? Draw rects, draw rects, and let's do a draw texts here. Clear. Draw rects, draw rects, draw rects. There we go. And of course a gfloat for color. Let's do a white text. Okay. I'll have a look when I do a break. Let's draw text here. And then the window draw texts. We want to in-place back our text draw here, text draw. Does all this compile? Yeah, it does. Okay, next thing is that we need to create some render data for it. For our auto reference text draw inside our window draw texts, we want to create UI, a vector of UI elements here. Text, render build text. We could do something like public static inline systems font reference get font return mp font. So let's just do that. Okay. Around the UI system. That's fair enough. I'll look forward to seeing it maybe sometime tomorrow then. Let's do that. Well, let's do text draw here, text. The font reference, then the text draw. Position.x, text draw, position.y. And then our texture color. Then our UI system 2. Can we access that UI system? Hide as well. Let's see, screen width. I'm not sure I can access them. And then the scaling will be 1.0. Let's see. I am allowed to access them. Okay. std vector UI element pointer out text elements equals a null pointer. Let's do if out text elements. We will do this. Otherwise, there's no point. And we will out text elements insert out text elements end, and then text begin and text end. Whoops. Yeah, we will append this to whatever is outside the thing here. Create render data. Let's see. Whoops. Okay, we have our text there. Great stuff. Let's try writing something that is extremely big. And let's see how it handles that. Inside our text here, we would like to access our window, I think. Window. Clipping area, we could use that for now. Clipping area, max dot x max width minus the minimum dot x. Let's try doing this. Did I? No. Well, let's print the max width here. Max width. How many pixels is that? 400 pixels, and this is how many pixels wide? 400 pixels wide, I think. Let's do 100 here. Well, now it won't show our buttons. Well, it shouldn't offset the buttons if it can't show it. I mean, 300. 200. Let's look up our button logic here. Or maybe it just doesn't care. Let's see. Let's see. Well, it won't draw it, but it will allocate space for it. I guess that's all right. I guess that's all right. But the text is confusing me a bit. All right, thanks for dropping by. I had a great time, and yeah, I'll do a break shortly. The text here, the max width is 400 pixels. Let's print the index of bounds. Index of bounds. $23 characters. Well, let's step into this function here. The text is a lot here. Well, yeah, the scaling itself doesn't actually. Oh, maybe I need to scale it by 50% when I do the size calculation, because I think the width calculation should be different inside the actual drawing stuff. Yeah, there you go. That's the error. It was the same error inside the drawRect function. So yeah, when we calculate outside clipping space, we need a scaling factor of 0.5%. Okay. So that's it for text rendering. We can also do some button text. but I'll do that after a break. So I'll be ending the stream here, at least for now. I'll probably do a bit more work on some more UI elements, and then, well, yeah. Of course, we have the dragging stuff here, which I need to implement. So what I need to do is to create a roadmap here to do new new let's see, I'm just thinking about something else. The text size here, we will know the bounds here. So yeah, if I calculate that, I can also use that to create some certain alignment. Okay, anyway. Add text to buttons. Add alignment to text. Then do a list box implementation. And then do some drag and drop stuff with the UI. Or do scrolling alongside. That's okay. Let me just see. So the handle, item handles. We actually don't increase the item handles list here anytime soon. Yeah, maybe we want to do that in the future. Anyway, that is the plan. So if you're watching this in the future, hopefully you found it helpful, insightful, funny, inspirational, or just something else entirely. Feel free to comment, like, or subscribe, or follow on Twitch. Hopefully I'll be seeing you around the